All right, so far we've talked about tangent, sine, and cosine. Now we're going to apply these to problems which are called angles of elevation and depression. So if we look at this picture here, there's 2 points of view, one from an elevation and one from down low on ground level. So if we look here, if we're on ground level looking upwards, that's called the angle of elevation. We're looking up. So if you take a look here, this is your sight line normally, and this would be the vision up, and that distance is going to be an angle. From the airplane, from something high, you're looking straight, and then from a distance, we're looking down, and that is going to be called an angle of depression. Now, although these are 2 different terms, we're going to all treat the angles as angles of elevation because angles of elevation and depression are the same, because they're actually alternate interior angles. These sight lines right here would be considered parallel lines, and this diagonal sight line is a transversal, and so we have 2 congruent things. So anytime we have an angle of depression, we're going to move it down here and make it an angle of elevation for simplicity. All right, so if we look here just to illustrate this point further, angle 1 is going to be the same as angle 2. Angle 3 is going to be the same as angle 4. Okay, and again, why are they the same? Because they're alternate interior angles because of the sight lines that are parallel to each other. All right, you're gonna get lots of word problems, and so we need to draw pictures, right? And so there's key things in the pictures. So a surveyor, that's a person, stands 200 feet from a building. So we have a building and we have the person, and we know the distance is 200 feet. All right, and it's measuring its height with this tool called a theodolite. And that's just a measuring tool. It looks like a tripod that measures angles. Okay, and that's going to become important later on. All right, the angle of elevation to the top of the building is 35 degrees. So this angle, when we look up, is 35 degrees. We want to know how tall the building is. So what we're going to find is this side right here. Okay, this side right here. So based on the angle, this would be opposite, this would be adjacent. So if we remember, opposite and adjacent is going to be tangent. And then at the very end, what we're going to do is add 5 feet, because the height is measured from here to here, but this is the 5 feet of the tool. So when we have these things where they have heights, most times we're going to either add or subtract. So that's really important that we pay attention. So we have tangent. When the variable is on top, we cross multiply. So in the calculator, tangent 35 times 200, and we'll get a height of 140, but we can't forget to measure the distance of 5 at the end, so 145 feet. All right, let's take a look at this. Now an airplane is flying 3,500 feet above the ground, and it begins a 2-degree descent. So the angle of depression is 2 degrees, right? And it wants to know how many miles from the airport is the airplane. So again, here's the height, and we have our picture. Remember a few minutes ago, angle of depression is the same as an angle of elevation. So down here, this is your angle, this would be opposite, and they want you to find this. Now this was confusing because it might make sense to find the bottom, but they said the airplane to the airport, not the distance on the ground to the airport. So the words are going to give you clues. Okay, so this is going to be sine, opposite and hypotenuse. So now the variable's on the bottom, so we're going to switch these 2 and then divide, and we're going to end up getting a distance of about 100,000 feet. And if we end up converting that into miles, it's actually about 19 miles away, which would make sense if you're about 19 miles out that you would begin a descent towards the airport. All right, 2 buildings are 30 feet apart. The angle of elevation is measured here. They want to know the difference in height between the buildings. So in this case, we don't really care what the height of this is or the height of this. We just want to know the difference between the 2. And so here's our angle, and then here's our side, and this is going to be tangent because we have opposite, which is what we want, and adjacent, which is what we're given. And so because variables on top, we cross multiply, and we get a distance of about 10 feet difference between them. So about a 1 floor difference, about 10 feet for every floor of the building. All right, down here we have a 6-foot man, and he's 12 feet from the base of a tree, and he wants to know the angle of elevation from his eyes, right? What is the angle of elevation if the tree is 54 feet? So this one's a little bit tricky, so we have to be careful of that. So here's our angle, right? Here's the tree we know is 54 feet, but we have to subtract off the 6-foot distance. right? So the whole thing is 54, but if we add 6 plus 48, that would give us the 54. So this is the triangle we're gonna end up using. Now when we have to find the angle, we're gonna use that -1, that inverse button. So we would do tangent -1 of this fraction, and you would end up with an angle of 75 degrees. Okay? So hopefully that makes sense. Some story problems. Reading is very, very, very important, so make sure you read it very carefully.